So, good afternoon, everyone. Myself, Dr. Rajesh Mehra from Electronics and Communication Department. And I would like to thank Professor P.K. Tulsi for inviting me to deliver this talk on emerging areas in the area of electronics and engineering research. So, I'm really thankful to ma'am. So, my presentation will include the following points, and we are going to discuss these points in detail. So, outline of this presentation, first we are going to discuss why we need research. Then we are going to discuss some emerging areas of research. Then what are the existing challenges and how we can go ahead to solve or to find out the problems for the solution for those problems. Then we are going to discuss some design tools available in the market for starting your research. Then we are going to perform the classification of different areas, and finally we have to conclude our session. So first of all, what is the need of research? Why we go for research? Actually, in modern electronic systems, all of them demand you can say high performance in terms of accuracy. You have to provide the solution and it should be accurate, it should be error free, your system should be reliable, it should work for longer period, and the performance of your system should be very high in terms of speed. It should work at high speed, and power consumption of your system it should be less. Your system should be less in size and less in weight. Yes, whatever product you are going to design, it should be cost effective, otherwise it is not going to survive in the market. Yes, time to market factor should be very less, otherwise some other competitor is going to launch their product in the market and you will be out of the race. And yes, ease of modification, because at present electronic industry is changing very fast, so your design, it should be flexible and modification should be easy in your design, so you have to consider this point also. Ease of testability means once your product is in working condition, if there is any fault, then its testability should be easy and it should be easy to locate the fault. So these are some basically you can say areas on which normally researchers work, and they try to improve maybe one or two out of these different areas. So most of the researchers directly or indirectly work on these parameters. Then emerging areas in the electronics and communication engineering, as our earlier speaker Dr. Rakesh, he was giving some broad areas related to computer, and you can find out some of those areas here also, because all these areas are interdisciplinary. So presently we can't say we are core electronics and communication, and we prefer to select one topic that is interdisciplinary. So some areas may be common with computer science, may be common with mechanical department, but these are interdisciplinary and you can go ahead with these areas, and there is no problem. So these areas are digital signal processing, audio and video processing, image processing, wireless communication, mobile communication, satellite communication, embedded system design, VLSI design, wireless sensor networks, network security, reconfigurable system design, Internet of Things, and robotics. Here you can see that wireless sensor network was discussed earlier. Network security is also interdisciplinary kind of area. Then IoT, Internet of Things, it is common for every you can say engineering field. Robotics, it is also used by computer as well as by mechanical engineer. So these are interdisciplinary, and we can go ahead with any one of these emerging research areas. So what are the existing challenges? Actually, whenever we go for any electronic system design, and in most of the applications we have discussed earlier in our previous slide, whenever we perform any you can say whenever we perform any operation, in that operation most of the times we multiply and add. whatever we are going to perform, it will be most of the operations use multiply and add operations. And as Dr. Rakesh said, signal is going to come from the real world. We are dealing with signals which are coming from real world. We have to process those signals and we have to give the response in certain time. So time bound output you have to produce. You can't wait for much time. You have to give the solution in very shorter time. So most of the operations we perform in our these applications, directly or indirectly, these operations comes under the category of transformation, convolution, correlation, and all these operations are performed with the help of multiplication and addition. So it means that whenever we have to design these systems, we need multipliers, adders, and memory elements in hardware if we want to implement this in a hardware environment. Transformation means you have your signal in one form, and there is a need to convert that signal from one form to another form. I will give you one example of this. What is the need of transformation? First one is this one. If you can look at these two waveforms, and if you just analyze these two waveforms, I think you can understand it is very difficult to analyze. You can't give any analysis of these two waveforms. So from here we can say that when analysis of two waveforms is difficult to perform, then you have to transform that data from that form to another form. So transformation is required at that point. So we will this data is in time domain. We will go for frequency domain. We are going to transform the data from time domain to frequency domain. Here you can see that these two waveforms include signal that consists of two frequency components. In our earlier waveforms, you can't predict, but here you can see that two different frequency components are available. So by changing the form of the signal, you can analyze the signal. This is one example of transformation, why we need transformation. Another example of transformation is whenever you click photographs, whenever you record videos, there is need to compress the data. For compression of data, you transform the data from one form to another form. And example of your transformation is MP3, MP4. These are nothing but behind MP3 and MP4, different kind of transformations are working. Then convolution. Convolution is nothing but filtering, and filtering is required in every field because signal is coming from real world and it is mixture of noise and wanted information, and there is a need to eliminate the noise from the wanted signal, and you have to produce that signal without any noise. So you have to perform the filtering, and filtering is required in each and every field. So convolution is nothing but filtering. So you have to perform the filtering part. Here you can see that the first signal is ECG signal. This is the original signal, and the second one is ECG signal with noise in it. And what will be the purpose of your filter? Purpose of your filter, you have to design a filter, and that filter is going to take that noise contaminated signal, and the purpose of the filter is to eliminate the noise, and it has to produce an output that will be closer to the input. So you have to filter out the noise, you have to produce one output, and that output will be closer to the input signal. So convolution or filtering is very important. Then correlation. Correlation is basically comparison between two signals, and it is also required at present in each and every areas. Here this example is for radar. In case of radar, we transmit one signal, and then we receive the signal, and then we compare these two signals in order to find out the target, if target is present or not. You are sending one signal, this is the transmitted signal, then you receive these two signals. If you see again, you can't analyze these two signals. what is this all about? Again, we are going to perform the correlation. Here you can see that in the first waveform there is one peak, sharp peak, and the second one there is no sharp peak. So that peak indicate that aircraft is present, and the second one, it means aircraft is not present. So basically you are transmitting one signal, you are receiving the signal from the target, you are comparing them. If there is any peak, it means target is present. If there is no peak, then target is not present. So this is the example of correlation. Apart from this, you are if you will see different examples these days in security. Even in our laptop, you have now thumb. You can open your laptop with the help of thumb or any finger. This is your attendance, biometric attendance. Your data is saved. Your data is saved in the database, and whenever you put your finger on that area, that will be compared with the data present inside that comparison. If it is matching, only then your laptop, it will be open, or your name will appear on that biometric attendance. So that is one, your ATM cards again. So these are some examples of correlation. So these three things are normally used in each and every field: transformation, convolution, and correlation. So basically in all the fields, we directly or indirectly perform either correlation or convolution or transformation. For performing these three operations, you have to use multiplication and addition along with memory to save the data. So to start your research, you should have good knowledge about the design tools. What are the design tools available with the researcher? So design tools can be divided in two categories: simulation tools and implementation tools. Simulation tools are similar, as my friend Dr. Rakesh said. Whatever you are simulating, you are designing some system, you are designing some algorithm, you are simulating it, and you are just comparing the performance of your algorithm with existing algorithms. But your work is still simulation. You are not actually implementing that work on environment, in real environment. You are up to computer, developing the algorithm, simulating it. So whenever we are performing our research on simulation tools, we always work on reducing the error. We have to reduce the error, or sometimes you try to reduce the resources. Resources in terms of multipliers and adders and memory, that effectively reduce the cost of your system. So example of these simulation tools are MATLAB, QualNet, Network Simulator, so many Scilab, so many other softwares are also there. But if you are designing something, simulation of that particular thing on PC, it doesn't mean that that same thing is going to work in actual environment, because implementation in actual environment is totally different. So if you really want to implement that thing on actual environment, then you have to move from simulation tool to implementation tool. You have to develop an hardware where you can make your system, and you can use your system, or you can check your system in actual environment. So these, whenever you work in these implementation tools, then you can improve. Then what are the areas of research? We can work on speed. We can improve the speed. We can improve the area consumption. We can reduce the area. We can reduce the power consumption of the system. And example of such softwares are Xilinx ISC, Cadence, Synopsys, Mentor Graphics, etc. So broadly, whenever we work, either we work on simulation part or we work on implementation, depending upon the software available with us. If we go for classification, broad classification of our research, mainly we work on four major parts. First, either we use GPP for our research. GPP here stands for General Purpose Processors. General Purpose Processors are nothing but your microprocessors. Our PCs are using microprocessor. They can be 16-bit, 32-bit, 64-bit. So you can perform your research on general purpose computer. Whenever you write your algorithm, you use computer, you simulate it on computer, and that is basically your microprocessor based research. Second is your ASIP, application specific integrated processors. And under this category, two processors are there. One is microcontroller, another is DSP. Either you can work in microcontroller or you can work in DSP. DSPs are used when you are dealing with signal flow kind of applications. Signal flow kind of application means signal is coming from real world. You are taking the signal, you are processing it. After processing your signal, you are sending it to the next unit. That is data flow kind of application. For example, whenever you are recording a video, you are recording the video, that video is captured, then that video is transformed into MP4, means it is compressed, and then it is sent to the hard disk. Whenever it is required, you are going to retrieve it. So in that case, you can use DSP. And microcontrollers are used where you want to control some physical devices. For example, you press some key of your remote and some physical device is going to on. The physical device here means your tube light, your fan, AC, whatever it is. So by giving some physical input, you want to control some physical output. So for control kind of applications, we use microcontroller. For data flow kind of applications, we use DSPs. This is another area where you can work. And then PLDs. PLD stands for programmable logic devices. And there are two classification in this one, CPLD and FPGA. CPLD here stands for complex programmable logic devices, and FPGAs are here for field programmable gate arrays. These are used for, you can say, reprogrammable platforms. You can use one FPGA for number of applications. There is no restriction, means you can use this FPGA for this particular application only. You can use this FPGA for any of the applications, means these are more flexible. Then ASICs, application specific integrated chips. These are used for specific applications, means you design some chip and that chip is going to work for that particular application. You can't use that chip for any other application. ASIC means it is application specific. You have to use it for that particular application. So these are four major areas. So you can work on any one of these areas depending upon the tool available with you, whether you are using simulation tool or implementation tool. If we look into the flexibility wise, ASICs are less flexible. And when we go upwards, PLDs are more flexible, ASICs are again furthermore flexible, and GPP they are the maximum flexibility is there in case of general purpose processor. As you can see that computers we can use in any other field. We can use it for civil engineering, we can use it for mechanical engineering, for electrical, electronics. So we can use it for any area. Likewise, if you go for the performance wise, it is in other direction. Performance of ASICs is best. They are the optimal in all sense. They can give you better power, means low power consumption will be there, high speed, right? Area consumption will be less, and performance wise they will be better. But they are not flexible, means they can be used for that particular application. They cannot be used for any other application. So these are some. So this is the detail of some general purpose processor already discussed. ASIPs already discussed here. ASIPs are microcontroller and digital signal processor based. And CPLDs, FPGAs, they are more flexible. ASICs, their advantages and disadvantages already discussed. They are useful when bulk production is required, high speed is required. They are energy efficient, but their disadvantages are long design time, they are less flexible, high cost. And finally, different applications where we can perform our research. Applications: mobile communication, traffic control, office and home automation, automobile. You can use research in this area. Consumer electronics is there. Then wireless communication. At present 5G is going on. Industrial automation. You can use your research in industrial automation also. And now finally conclusion. Researcher may select any one of the means discussed areas depending upon the inputs in term of literature, whatever literature you have, what is the input with you, your software, hardware. once all these inputs are there with you, then you have to produce output in order to provide optimized solution in terms of speed, power consumption, area consumption, cost, time to market, and flexibility. So these are some areas and some you can say possibilities where electronics, not electronics, maybe computer, electrical, they can also go ahead with their research in these areas. And with this, I just close my session. Thank you very much. And now house is open for queries. You can ask your questions, please.